Hello and welcome to this lesson on completing the square to find the vertex of a quadratic graph. So we're going to start by just remembering the fact that if we square a positive number, we get a positive answer. So positive 5 multiplied by positive 5 is positive 25. And if we multiply a negative by a negative, so if we square a negative number, then we also get a positive answer. So negative 5 multiplied by negative 5 is positive 25. So that means when we square root 25, we can get two possible answers, positive 5 and also negative 5. So here is the graph of y equals x squared. So it has this sort of symmetrical shape because whenever we square a negative number, we get the same answer as we do when we square its positive pair. So for example, we can see here that x equals 2, we'll square that and it will give us 4, and x equals negative 2, we'll square that and it will give us positive 4 also. Okay, so what I'd like you to do here is pause the video and have a go at completing the square on this quadratic expression. And this is a skill that you should already know how to do. So pause the video and have a go at this one. Okay, so we know that x squared is going into this top left-hand part of the grid, and we've got 6x here, and we're going to divide that equally between the two squares in our grid here, so that's going to be 3x and 3x. And now we're going to fill in the top and the left-hand side. So we know that we need an x multiplied by an x to give us x squared, and then we must have a positive 3 here because positive 3 times x is positive 3x, and equally down here. So we're looking at x plus 3 all squared, and that will give us, in this part of my grid, positive 3 times positive 3, which is positive 9. Now, my expression didn't have positive 9, it had positive 5. So I need here for these two parts to add together to make positive 5. And so I'm going to need here to have a negative 4. So my quadratic expression here, from x plus 3 squared, I'm getting the x squared and the 6x part, but I don't want 9, I want 5. So this is going to be identical to x plus 3 squared, subtract 4. Okay, so how can we use this completed square form to find the vertex of our graph? So what is the least that if we look at this completed square form, what's the least it can possibly be? Well, the least that x add 3 squared can be is 0. And if I want this x plus 3 squared here to be 0, then x must be negative 3. So I would get a negative 3 add 3, and that would give me 0. It can't be less than 0, because even if I make what's inside the bracket negative, then when I square it, it will be positive, because as we looked at on the last slide, when you square a negative number, you get positive. So x plus 3 squared can be positive, but it can't ever be negative, so the least it can possibly be is 0. And if the least this can be is 0, then when I subtract 4 from it, altogether the least that this whole expression can be is negative 4. And when is this going to happen? Well, as I said, this will happen when what's in the bracket here is 0, and that will happen when x is negative 3. So the smallest point on this graph, the minimum point, will be at x equals negative 3, and it will have a value of y is equal to negative 4. So just take a look at the completed square form and the coordinate at which this graph has its minimum value. Well, we've got the same y value as we are subtracting here, including the negative, but the x value is the same as what's inside the bracket, but just with the opposite sign. So we've got the opposite sign and the same sign. Okay, so let's have a look at what this looks like graphically. So this is what we just completed the square on, and we just worked out the minimum value from in completed square form. And when I'm talking about the vertex and the minimum, I'm talking about this point here, the very, very bottom point that the graph reaches. And as you can see, this is happening when x equals -3 and when y is equal to -4. And this is called the minimum point, or sometimes it's called the vertex. Sometimes it's called the turning point as well. Okay, so just to generalize what I had already said, if we've got a completed square form of x subtract p, then the x coordinate of the minimum point will be p, positive p, so it will have a different sign from what's in the bracket. And the y value will be, in this case, positive q, so it will be positive q. So this one has the same sign as we've got on the outside of the bracket. Okay, so what I'd like you to do here is to take each of these quadratics and to write them in completed square form. Once you've got them in completed square form, I would like you to try to read off the turning points. Just notice that for these first three, there is no constant. So that means you need to add or subtract something so that you get a zero constant, just like you did when you were practicing this in previous lessons. Now, some of these get really, really tricky because they start to generalize. You can have a go at those, but you will find them really difficult. So these are extension. So pause the video here and have a go at these questions. Okay, so I'm going to run through the answers for these. So the first one, I should have x add 1 squared, subtract 1, and therefore the turning point will be -1, -1. So remember, this x coordinate has got the opposite sign of what's in the bracket, and the y coordinate has the same sign. Right, next one, x add 6 all squared, subtract 36. Remember that we're always halving the coefficient of our x here. And when we expanded this bracket, we will get a plus 36. We don't want any constant at all, so we need to subtract all of 36. So our minimum point, our turning point, will be -6 and -36. Next, we should have x subtract 11 all squared, subtract 121. So this one, we should have +11, -121. And then for the next one, x plus 3 all squared, add 1. So our minimum point will be -3, +1. So I'm going to run through these answers. If you can mark your work. This one is a super tricky one because you had to halve 1, which gave you a half. So really well done if you got this one correct. Super tricky. Again, a tricky one because this isn't an even number. So when you halve it, you might have put 2.5 in your bracket. Now that's fine. It's actually easier to leave in fractions because when you come to expand your bracket, it's easier to square a fraction because it will just give you 25/4. Again, super tricky because we've got some fractions, and then we got into algebra, so these are really, really hard. If you even attempted these, well done. Okay, just pause here for a second for you to mark your work, and then we're going to have a look at an exam question. Okay, so here is an exam question from a higher tier GCSE paper. It says the expression x squared subtract 8x add 21 can be written in the form x subtract a, and that should be squared there. Something's happened here when I've taken this exam question from Exam Wizard. It should be x minus a squared add b for all values of x. So what this is telling you is completed square form. That's what this is. When you see this, that's what you should think. It looks a bit scary because it's been written in general algebra, but you should just be thinking, okay, they're asking me to write this in completed square form, and then they're asking me to say what the value of a and b are. So it then goes on to say, here is a graph which has got exactly the same equation as the one you've just completed the square on. Can you say what the minimum point of this graph is? So you've just got to use your completed square form then to give the coordinates of the vertex. So I'm going to pause here for you to have a go at this exam question, and then we will go through the answers. Pause the video and give this a go. Okay, so this exam question looks a bit scary because it's been written in a really formal way. We haven't even talked about this f of x notation yet, but it is clearly telling you that that is the equation of the graph. So what should you have done? You should have completed the square to get x subtract 4 squared, add 5. So it's taking you here through how you would get the marks. So if you realise that you needed to halve the negative 8x to get x subtract 4 squared, you get a mark for that. You then get a mark for subtracting 16 and adding 21. So essentially, if you just put add 5 here, which is the way that I've taught you to do it, that will get you the marks. And then for taking your completed square form and reading off your a and b, because it had written it as x subtract a. So you need to realise that your value for a then is going to be positive because the subtract has already been taken into account. So the third mark for saying x equals 4, a equals 4 rather, b equals 5. Then the mark for the second part looks really complicated, but it is only 1 mark. And the reason it's 1 mark is because you've just got to read off from your completed square form, x subtract 4 squared, add 5, that your minimum point or your vertex is going to be at the point 4, 5. So if you got that correct, well done. You've just answered a GCSE question on completing the square and using it to read off the vertex.